Water falls from the sky in the science of meteorology. It's an incredible feat of physics that something so heavy is transported by air around the globe. But that's a good thing. Fresh water, H2O, enables life. Water is soothing. In many cultures, it is spiritual. It cleanses our environment and our homes. It's in every food we eat. Every creature needs water to survive. It makes up the majority of our bodies. Earth has a great deal of it. It's why Earth is called the blue marble. From space, we see the amount of water on the planet in the oceans. Oceans cover more than 2/3 of Earth. The seas are just one place where water is stored. Seawater is salty. But a closer view of the planet shows fresh water. Not just in lakes and rivers, but in glaciers and in clouds. Water exists on Earth as liquid in oceans, lakes, rivers, and streams. Water is stored underground in aquifers. Water floats as vapor in air and sits in snow and ice. It constantly changes phase and is recycled through weather in the water cycle or hydrologic cycle. Start with water in the oceans and lakes and rivers. Heat from the sun causes it to evaporate. When water evaporates, it retains all of the energy that was put into it to change phase. This stored energy is known as latent heat. Water changes phase from a liquid to a gas called water vapor and rises into the air. Wind redistributes this vapor around the planet. When the air becomes saturated with vapor and can hold no more, the vapor condenses into clouds and releases the latent heat, warming the air. Water is highly efficient at holding and transporting thermal energy. Water vapor also condenses onto objects, often at night when winds are calm and the sky is clear. Water droplets appear as dew on grass, cars, and other things that cool down fast. The temperature at which this happens is the dew point. You can tell dew is not rain because the sky is typically clear when you see dew. It's a pretty sight when beads of dew form on spider webs. When dew is heavy, it drips off to the ground, and when the air and ground warm, dew will evaporate. If the temperature is below freezing, then water vapor forms ice crystals on those objects, and that's called frost. Frost indicates that the temperature right at the ground or on a surface is at or below freezing. Window frost lets us marvel at the delicate and detailed designs that develop. It's an artistic manifestation of meteorology. Frost on window panes, or outside, is the same as frost inside a freezer. It's when water vapor goes directly to ice without changing into water droplets. That's called deposition. The temperature at which ice crystals form is also called a frost point. When temperatures are below freezing, you won't always get a frost if there's not enough water vapor in the air. On the other hand, it's also possible to get frost when the air temperature is above freezing, because the temperature right at the ground or on surfaces is freezing or below. Frost and dew don't fall from the sky. They form right in place when water vapor changes phase. Clouds can be made of tiny droplets of water, or they can be made of ice crystals, depending upon the temperature and how they form. Some clouds are a mix of both water droplets and ice crystals. Clouds are an effective vehicle for transporting fresh water around the planet. When the cloud droplets or ice crystals grow large enough, they fall as rain, snow, sleet, or hail, depending upon the temperature. Any form of water that falls from the sky is called precipitation. All forms of precipitation are hydrometeors. That's where the word meteorology comes from. It's the study of precipitation. When precipitation is heavy, we see and feel the incredible amount of water that can float in the air in both weight and in volume. Much of the world knows rain, at least in the warm season. Rain can be light, moderate, heavy, or extreme. When rain hits the ground, it takes many different paths. Some rain will accumulate in large puddles and sit in place. Other rain will run off downhill into a creek, river, or lake. Some rain will slowly soak into the ground. That's called percolation. Rain and melted snow generally do all of these things, depending on what type of surface they fall onto. Rain that sits in puddles may rapidly evaporate once the rain ends, especially if the air is warm. The warmer the air or surface is that the rain falls onto, the faster and more dramatic is the evaporation. Snow can also go directly from ice to vapor in the process of sublimation, but that's a much slower process. Moisture pulled from the ground in tree and plant roots and given off from their leaves is called transpiration. That puts water back into the air. Any of the water that percolates into the ground will recharge aquifers and may work its way into a river or lake. Water in a river, lake, or ocean continues the hydrologic cycle. If you spill a glass of water, sooner or later it all evaporates. After a summer shower, we see rapid evaporation from hot rooftops, pavement, and roads. Weather drives the water cycle as a never-ending process with no single beginning and all parts happening simultaneously. As a liquid, water flows, changes shape, and is capable of storing tremendous quantities of heat. Liquid water can erode rocks and carry sediment and other heavy objects. As a gas, water vapor also changes shape, flows, and stores latent heat. It is more efficient at holding additional heat from the sun than dry air is. As a solid, ice is rigid. It can reflect sunlight to insulate the ground. Ice can shatter and erode rock. It is less dense than liquid water, so it floats. Ice can dam rivers to create floods. Moving water can do work by turning wheels or by turning turbines to generate electricity in a hydroelectric plant. Water and the water cycle play a tremendous role for the planet. Each form of water over large areas modifies weather, and all weather modifies each form of water. Too much water that rises in one spot is a flood. Floods can cover small areas like a road, medium areas like a neighborhood or farm, or large areas like a city. Flash flooding is the fastest type of rising water. Flash flooding is most common when heavy rain falls over the same spot and can't drain fast enough. The floods may come from intense thunderstorms sitting in place, or from several hours of heavy rain. Water always runs downhill and rises in the low areas within a watershed. Drainage systems may be overwhelmed, leading to street and neighborhood flash flooding. Creeks and rivers may also rise quickly from extreme runoff and then overflow onto nearby roads and property. Both of these may occur together. Floods could be standing water or moving water. Swiftly moving water, especially when it is carrying debris, has the energy to eat away at hillsides and road underpasses to undermine the soil. In the worst cases, a road may be washed away beneath the floodwaters. Flash flooding takes lives because people underestimate the power of moving water, even when the water seems to be shallow. Every cubic foot of water weighs 62 pounds. A vehicle crossing water that's not very deep can easily lose traction and be swept off a roadway into deeper water. A person walking through fast-moving water that's less than a foot deep can easily lose footing and be knocked down and carried away. River flooding is a slower and more prolonged process. In the snowbelt, river flooding is seasonal. The warmth of spring triggers the melting of a snowpack built up over the winter. When snowfall is far above average and then temperatures rise above freezing for long periods, a huge amount of meltwater will run off and enter the rivers. In extreme cases, the rivers increase in width, depth, and in speed. They spill over their banks and flood low-lying land in floodplains for days or weeks. It's a natural cycle, but when roads are cut off and homes and communities are isolated or impacted, it's a disaster. Rivers with melting ice may also rise further if the ice creates dams. Any river causes erosion and may carry large amounts of sediment or debris. From satellite, we spot an enormous plume of sediment leaving the Mississippi River, along with sediment in the bays and lakes of southeastern Louisiana. This followed spring snowmelt in the northern plains and record rainfall upriver. Slow erosion happens on timescales of decades and years in large rivers. In rapid flooding, erosion occurs over days and even shorter periods like hours in rivers, streams, and creeks. We see erosion in neighborhoods, not just from flooding, but from runoff that continually focuses moving water over one area. This all increases the potential for destruction of property and disruption to society. Rising water that damages property is a flood, but it is usually not covered in standard property insurance. Find out if you live in a flood zone or floodplain and if separate flood insurance is required or suggested for your community. A flood watch means flooding is possible, and you should be prepared to take action. A flood warning means flooding is happening, and you must take safety steps immediately. With population growth and expansion, many homes and businesses are developed closer and closer to floodplains. A floodplain is the natural basin for river overflow. Floodplains are not normally wet, but they go through cycles of being dry and holding water. New development also can redirect and increase the flow of water runoff, making water rise in places where it never flooded in the past. Development sometimes simply hides the existence of floodplains, but when water rises, the floodplains reappear. These are things we must account for in long-term planning for the threat of floods. Most of the world's population can relate to rain. Rain is liquid water that falls from clouds as precipitation. It replenishes our lakes, rivers, aquifers, and fresh water supplies. Rain cleans the air and makes it possible to raise livestock and grow crops. In the extreme cases, lack of rain results in drought. while too much rain is a hazard that creates flooding and erosion. Rain can be light, moderate, or heavy, depending on the type of cloud from which it falls. Heavy rain is common in big low-pressure systems like nor'easters, tropical storms, and hurricanes, or even just from thunderstorms that move slowly. Light and moderate rain is routine from stratus clouds found within broad regions of low pressure. Steady rain from stratus-type clouds tends to cover extensive areas since the clouds are wide and spread out. The lightest rain is called drizzle. Drizzle is tiny water droplets that slowly fall and dampen everything. Drizzle usually doesn't add up to much. Rain that falls briefly and stops is called a shower. We get more showers from convective or cumulus-type clouds. Since these clouds can be small, it's not unusual to get a shower on one street, and just a few blocks away, the ground stays dry. Showers may be light, moderate, heavy, or intense. Snow also falls as showers from cumulus clouds. Snow is the winter equivalent of rain, but snow is not simply frozen water. Snow is crystals of ice forming directly from water vapor that bind together to create flakes. A snowflake can be as small as a grain of sand or as large as a button. These historic snowflake photographs taken in the early 1900s show an array of artistic design. A single snowflake is composed of hundreds of ice crystals. Electron microscopes display detail to deliver insight into the process of water vapor changing to hexagonal ice crystals and growing geometrically. Microscope photography presents the precision and beauty in which these delicate flakes evolve. With ice crystals forming a lattice, snowflakes may be flat, columns, or needles. All branches occur at an angle of 60 degrees based on the molecular structure of water. Snowflake sizes and designs depend on the amount of water vapor available when they form and how the temperature varies in the cold air where they develop. Individual flakes may have a simple appearance, or one that ranges from elaborate to ornate. No two snowflakes are truly the same. While many snowflakes are not perfectly symmetric, they all start with 6 sides. It's not unusual for a snowflake to have different types of ice crystals, all stuck together. As they fall from miles up in the sky, the flakes tumble, break apart, and merge. The heaviest snow falls when the air temperature is closer to freezing. This is when there is a relatively high amount of moisture in the air. Some of this snow may halfway melt into sleet before reaching the ground. When the air temperature is close to freezing, it's not unusual for an inch of liquid to produce 10 inches of snow. On the other hand, very cold air produces snow that is very lightweight and fluffy and may easily blow around after landing on the ground. When it does not accumulate, that's called flurries. The colder the air is, the less moisture we find in it, so colder weather tends to produce less snowfall. Even on a sunny day, blowing snow that reduces visibility to under a quarter mile when the winds are over 35 miles per hour for several hours is called a blizzard. The definition of a blizzard does not include temperature. It's only about wind-blown snow that makes it hard to see. Snow has a huge impact on transportation. Large snowfall amounts make travel hazardous. Municipalities may spend hundreds of thousands of dollars each year to keep roads safe and to allow commerce to continue. Big cities spend millions of dollars annually for snow removal. Snow gives good opportunity for recreation and exercise. Sledding down a hill usually brings smiles to many faces as long as people are properly dressed and the temperature is not too low. Cross-country skiing and downhill skiing are popular in many regions. They continue outside of winter, too, in high elevations where snow is slow to leave because the air stays cold. Cold winter air for long periods is definitely required for ice fishing. When the surface of a lake freezes, the water remains liquid below. Snowmobiling is also another winter recreation that equally serves as transportation. Some of the coldest places on Earth are actually considered deserts, like Antarctica. Even if snow and ice is on the ground, it is a desert because very little precipitation falls. It's the lack of substantial precipitation over centuries that creates a desert. On the other hand, a persistent lack of regular precipitation over months and years leads to droughts. A drought is not just dry, it's much drier than average. A drought can be defined by how much below average the precipitation is, how arid the soil is, how little water is in the ground or aquifers, or by combinations of any of these. Regular precipitation is critical for humans and other species to maintain health and adequate food sources. Rain and snow can fall together in any combination. Snow that falls and halfway melts before refreezing, or rain that halfway freezes before hitting the ground, is called sleet, or ice pellets, or gruffle. When rain falls through air that is above freezing, but then makes contact with a surface that is below freezing, like pavement, vehicles, power lines, or trees, it freezes on contact. That is known as freezing rain or an ice storm. It may be slow, gentle, and silent, but an ice storm has great negative consequences. Light rain or drizzle accumulating as layers of ice is an extreme hazard. Ice storms can paralyze a city or a region. Power lines and trees often fall from the weight of ice. People may suffer without electricity and heat. Travel is nearly impossible. Glaze, or any thickness of ice, closes streets and highways. All-wheel drive does not guarantee total vehicle control. Trucks without chains lose traction and can only sit on inclines. Their weight and power is no match for ice on an untreated roadway. One single accident on a major travel route can strand thousands of people for hours. Hail is a different form of ice. It can happen in the warm season when the temperature near the ground is far above freezing. The white on the ground is not snow. It's a blanket of hail from a summer hailstorm. Hail comes from thunderstorms or clouds with a lot of rising air and ice aloft. Water is suspended in the sub-freezing air by rising air currents. It freezes aloft in a process that builds layers and layers. When the ice gets too heavy to be supported by the upward wind, it falls to the ground. Even though hail may partially melt on the way down, it can range in size from that of a pebble to that of a grapefruit. The larger the hail is, the stronger the upward wind or updraft is in the storm, and the more intense the storm can be. For example, 1/2 inch sized hail requires an updraft of about 35 miles per hour. 1-inch hail, or hail the diameter of a quarter, is caused by updrafts over 50 miles per hour. When hail is the size of a tennis ball, the updraft is at least 75 miles per hour. And for large hail, the size of a softball, the updrafts are over 100 miles per hour. From a distance, it's not easy to identify what type of precipitation is falling from a cloud, but it is easy to see whether it is light or heavy. For clouds that are high, precipitation may fall into a layer of dry air and evaporate before reaching the ground. That is called virga. The evaporation of precipitation causes air to cool, so oftentimes the wind becomes gusty beneath virga as colder, more dense air sinks from the sky. In extreme cases, this creates dust storms, especially in arid regions. Intense dust storms are known in the Middle East as haboobs. Dust storms can be far removed from the original precipitation and storm that caused them. Wind may travel for miles, picking up loose soil, sand, or dust. In a weather forecast, you'll often hear rain and snow predictions given as a percentage chance. The percent chance of rain is the statistical odds of measurable precipitation where you are. It does not tell you the intensity, quantity, or duration. That means in Central Florida, a 40% chance of thunderstorms can result in brief but very heavy rainfall, while in the Pacific Northwest, a 40% chance of rain may be a steady light rain that continues for a few hours. Some predictions use the percentage in a slightly different way, to tell you what portion of a city or county will get measurable precipitation. Annual precipitation amounts are controlled by wind direction, proximity to large bodies of water, temperature, and topography. The cycling of water between air, land, and sea as liquid, gas, and solid is critical to planet Earth and to life. The hydrologic cycle and meteorology are both interwoven and bound together. These are weather things.